Hello, class. This is Mr. Hart, and in this podcast, I want to go over the next part of the weather chapter, which is air masses and fronts. Okay, and we'll start with air masses. An air mass is just a large grouping of air, usually in the upper troposphere or lower stratosphere. Okay, and it can spread across many miles of area on the Earth. So you can kind of see by these different colored regions on this map where the air masses would be, and you can see they're quite large, spreading over many, many miles. Okay, and air masses are important because the characteristics of the air mass can determine certain weather phenomenon. Okay, so for example, if an air mass forms over the ocean, it's probably going to be very humid or moist. Okay, which is going to affect the weather in that air mass. If an air mass forms over land, it's going to be very dry. Okay, if it forms near the equator, it's going to be very hot and those types of things. So based on where these air masses are forming, we can have different weather effects. So we want to be able to classify where the air masses are forming and what properties they have. Okay, and so we came up with a system, and you notice that every single one of these air masses has two letters associated with it, one lowercase and one capital letter. Okay, and so there's a couple of different letters that we can use to classify them, but here are the main four I want you to know. Okay, so for the lowercase ones, that usually determines if it formed over land or sea. So if it formed over land, we give it the designation C, which means continental. Okay, it formed over land, so you would expect this type of air mass to be very dry. Okay, have very dry air in it. Okay, if a air mass formed over the ocean or over a body of water, we give it an M, which means maritime. Okay, so that type of air mass you would expect to be very moist or humid. Okay, because it has that ocean water kind of evaporated into the air mass. Okay, so those are the two lowercase ones I want you to know. And then the two capital ones I want you to know are T for tropical, okay, and P for polar. So a tropical air mass formed near the equator, so it's going to be very hot or warm air. And then a air mass that formed over the poles is going to be polar, so it's going to be very cold. Okay, so let's go back to the map, and we can kind of see this. Okay, so for example, this one right here, it has the designation MP. So M for maritime, which means it formed over the ocean, right? So it's probably very moist. And P for polar, so it probably is very cold because it formed near the poles. Okay, so we expect this air mass to be wet but cold. Okay, let's try this one over here. So C for continental, meaning it formed over land, so we expect it to be very dry. T for tropical, so it's near the equator, so we expect it to be very warm. So this air mass would have warm, dry air. Okay. And you'll notice there's some other letters like E for equator or A for Arctic and Antarctic. We won't worry about those ones. We're just focusing on those four that I showed you. Okay. So based on the type of air mass, okay, we can determine what type of properties it has. Okay. And again, these are the four letters I want you to know. Okay. All right. So air masses by themselves aren't super important in the way they or in the way that they affect weather. The most common way they affect weather is when they actually collide. Okay, so when two air masses collide, we get what's called a front. Okay, and the front is a meeting point between two air masses. So this is the very influential part of air masses. Not so much when they're by themselves, but when they actually collide. Okay, so if you've ever seen fronts on a weather forecast, they're represented with red circles or blue triangles, and we'll get to that in a second. But let's just note that it's this meeting point between these two air masses. Okay, so for example, you've probably seen on a weather report like a cold front coming in, and they draw this nice big blue line across a map. And when they do that, that's actually the meeting points between two fronts. So you can imagine over here might be a continental polar front, and down here on the right might be a maritime tropical, right? And so you can actually kind of envision this air mass going this way and this air mass going this way, right? And this line is where they're colliding. So kind of imagine this huge air mass over here colliding with this huge air mass over here, okay? And so when you see a front, it is physically a collision between these two air masses. Okay, so when they draw that line on your screen, that's what they're showing, this collision point. Okay. All right, so let's look at some of the different types of fronts. The main one that you probably see in Utah the most is what we call cold front. Okay, so a cold front is represented by blue triangles. Okay, and this is when cold air, okay, an air mass of cold air is kind of pushing on an air mass of warm air. Okay, so it's kind of plowing through this air mass of warm air. And as that happens, this warm air will start to rise above the cold air. Okay, because warm air naturally rises. So when the cold air comes in, okay, the warm air naturally will rise above it. Okay. And so warm air comes on top, cold air plows through, and so we get cold underneath, warm on top. And when this happens, we get a lot of cloud development up here. Okay. So you get a lot of clouds up in the atmosphere, and so a lot of times it's nimbostratus clouds, kind of the storm clouds. And so cold fronts are often associated with storms, okay, bad weather as this cold front's pushing through. Because of a lot of the cloud formation, you get a lot of storms. Okay, so that's a cold front. And this is a picture of a cold front actually moving in. And I really like this picture because you can really kind of see almost that bulge from the cold air mass pushing in and the warm air mass coming up above the cloud line. Okay, and so again, you can see kind of stormy clouds. Again, kind of bad weather associated with cold fronts. So that's the first type. The second type is a warm front. Okay, warm fronts are associated with red circles. Okay, so blue triangles for cold fronts, red circles for warm fronts. And in this case, the warm air is pushing on the cold air. Okay, so the cold air is going this way, warm air is coming up, and so as it rises, it also forms clouds. But instead of getting a lot of storm clouds, you mostly get the cumulonimbus clouds up when a warm front's coming in. So warm fronts are associated with a lot of bad weather, but it can cause a lot of clouds. Okay, sometimes you get fog with warm fronts and things like that. So warm fronts aren't as bad, not associated with as much bad weather. Okay, but that's a warm front. And again, these clouds are usually cumulonimbus clouds, the kind of the towering type that we talked about before. Okay, and it just kind of moves up this ramp and forms this huge tower as it goes along. Okay, so there's cold fronts and there's warm fronts. The last type of front that we want to talk about is what we call an occluded front. Okay, so an occluded front is kind of a special case. This is actually when a cold front catches up to a warm front. So you actually have three air masses colliding with each other and two fronts kind of hitting into each other. So they represent with these purple triangles and circles, okay, kind of combined. You can kind of imagine the triangles and circles are kind of combining into this one front, okay. So if you look on a map, here's a cold front coming in, here's a warm front coming in, and so then this purple area, the purple triangles and circles are the occluded front. They are associated with some pretty bad weather as well, not so much because of the air masses themselves, but just because there's so much differences in pressure and things like that. And so, again, you can imagine there's three air masses here. So maybe there's an air mass over here. Let's say this is continental polar. Maybe this is maritime tropical, and maybe this is maritime polar or something like that. And you can really see there's an air mass over here, an air mass down here that's kind of getting wedged out between the two of them, and there's an air mass over here. Okay, and so you literally have three air masses combining, or two fronts combining, and we get this low pressure area, a lot of wind and things like that in this occluded front right here. Okay, and so again, occluded fronts are also associated with bad weather. But mostly just lots of winds and things like that. Okay? All right, but that is all we want to cover for today. Again, just fronts and air masses. Let me know if you have any questions about them. Hopefully they're pretty simple. But again, let me know if you have any questions, and thank you for watching.